Okay, so I think we are live. If there is anybody in the chat section, please let me know. Am I audible? Just let me know, guys, everything is fine with my stream or not. Okay, yeah, let's just wait for some 10 seconds so students can gather. 10 to 20 seconds and we'll start our today's stream. In तब तक just tell me, guys, if everything is fine with my stream or if there is any issue, just let me know, or if not, just give me a quick thumbs up in the chat section. So I'll start our today's session. Okay, so I think everything is fine. Yeah, so in today's session we are going to discuss engineering mathematics PYQ set 01, which is from 2015. Why I am taking suddenly 2015 question paper, right? So you will ask me, because you know this year IIT Kanpur is IIT Kanpur exam करा रहा है, conduct करा रहा है इस बार. IIT Kanpur is conducting the exam in 2023 and in 2015 IIT Kanpur has conducted the exam. So that's why we are working on the question of IIT Kanpur. So we will know what kind of pattern we are going to face and what kind of pattern IIT Kanpur is going to, what kind of questions are there will be in the 2023 question paper. Right, so we are going to understand some pattern from there and also solve some question and also check their difficulty level. Okay, so let's start with our first question. So without wasting time, I'll start from the question, and at the meantime, if you have any question, you can ask me in the comment section, right? So I think everything is fine, we can start our questions. Okay, so if I'll see this first question, right, if gx is equals to 1 minus x and hx is equals to x upon x minus 1, right, then we have to find out the value of g of hx upon h of gx. So any idea, any of the student, how we'll attempt this question? So anyone, how we are going to attempt this question, right? So if I'll see this question, just see this question, it has g of hx and h of gx, that means composition, right? First I have to find out g of hx, that is composition of g and h, and second I have to find out h of gx, and then I have to divide those two, right? So let's find out what is g of hx. So if I'll take g of hx, so what is hx here? Hx is my x upon x minus 1, x upon x minus 1. So now when I'll use g function, I'll replace x with x upon x minus 1, because g of x is equals to 1 minus x, g of x upon x minus 1 will be 1 minus x upon x minus 1, right? Is it clear? Now what I'll do, I'll take the LCM. So what would I get? X minus 1 minus x upon x minus 1. So I'll get minus 1 upon x minus 1, right? This is in simplified form, right? Now I can find out h of gx. So let's find out h of gx. So what would I get from h of gx? So that means h of, what is gx? Gx is my 1 minus x, right? I have to take h of 1 minus x. Now let's replace, in place of x, I have to replace 1 minus x. So let's do that. 1 minus x and x 1 minus x minus 1, right? On solving, what would I get? I'll get 1 minus x upon minus x, right? This will I'll get. Now I have to find out g of hx upon h of gx. So let's do that. G of hx upon h of gx, I have to find out the value. So let's divide. So that means minus 1 upon x minus 1, 1 minus x upon minus x, right? I'll get this, right? Now I can write 1 minus x as x minus 1. So what would I get? minus and minus cancel, so I'll get minus x upon x minus 1 ka square, right? I'll get this. Now let's see which function I'll get. Now I can see that option D is not correct because I'm not getting this. Option B is also not correct. So either it is option A or it is option C, right? Because C and D are incorrect here. So what will be option A here? Let's find out. Hx upon gx, that means x upon x minus 1 upon 1 minus x. Now I can write 1 minus x as x minus 1, right? What would I do? I'll multiply with minus and on the outside of the brackets and inside of the brackets. So what would I get? I'll get minus x upon x minus 1 square. So which is this? This is my g of hx upon h of gx. So here I can say that that it is what? Hx upon gx, right? So this is my option A. So here option A is my correct option, right? So that's why from here I'll get that g of hx upon h of gx is equals to h of x upon g of x. So this means that there in 2015 there is a question of composition of function in GATE exam. Okay, so just let me know if anybody have a confusion in this question, otherwise I'll move forward to the next question. So let's just not waste time. If there is any confusion, guys, ask me in the chat section, right? Either it is how we write g of hx or h of gx, you can ask me, otherwise I'll move forward to the next question so that your time doesn't get wasted. Okay, yeah, let's see the next question. Here option A is correct, right? Okay, so again this is question from 2015. That means this is a limit question, so we have to solve one limit question, right? So to solve a limit question, I just know that if there is infinity by infinity, 0 by 0, this kind of format, I will use L'Hopital rule. But if I'll see here, it is limit x tends to infinity x to the power 1 by x. That means infinity to the power 0, right? And we know that we are not able to find the value of infinity to the power 0. Right, that is undefined for us. So how we are going to solve these type of questions? So just remember, guys, whenever you will find out x in powers, then how you are going to solve these type of questions. So let's first take y is equals to x to the power 1 by x. Right, now take log on both sides, right? Taking logarithm log on both sides. Right, now when you take logarithmic on both sides, what you will get? Log y, and on the right hand side, using log property, power will come in the front. So what would you get? 1 by x log x, right? That means function, if I'll take limit, and now taking limit x tending to infinity log y is equals to limit x tending to infinity log x by x, right? So we'll get this. Now if I'll see here, log x is, if I'll find out the limit x tending to infinity log x by x, both are infinity by infinity, log infinity infinity. Infinity by infinity is our undefined form, right? I can use L'Hopital rule. I know that if I have terms like 0 by 0 or infinity by infinity, I can use L'Hopital rules here. Right, so let's use L'Hopital. And what L'Hopital rule says, that differentiate numerator and denominator both. So let's differentiate limit x tending to infinity log x ka differentiation 1 by x and x ka differentiation 1. And here we have, to the right hand side, we have limit x tending to infinity log y, right? Now if I'll find out this limit x tending to infinity, what would I get here? Limit x tending to infinity will be 0, right? Limit x tending to infinity will be 0. Now here limit x tending to infinity log y. Now I'll take this log to the right hand side. So what would I get? I'll get limit x tending to infinity y e to the power 0, because logarithmic and exponential are inverse of each other. If I'll take log from the left hand side to the right hand side, it gets converted into exponential. So I'll get e to the power 0, which is 1. So here limit x tending to infinity y is 1. So e to the power 0, 1. So which option is correct here? Option C is my correct answer, and I can check here that option C is the correct answer. So guys, any confusion in this question? Just let me know, guys. Right, what we have done. So we know that whenever we have a power of x, power in terms of x, then I am going to use logarithmic function. That is going to solve my question when we have power, because what will happen, the power will come in the front of the function, right? And if it is in denominator, then I can use L'Hopital rule, right? Otherwise it will make it to 0 or anything, right? It is going to help me to solve the question, right? Okay, so guys, any confusion you can ask here freely. Just don't get confused at any step, right? Because these are important questions. They have asked these kind of question in your 2015 GATE exam, which is conducted by IIT Kanpur, right? Okay, so let's move on to the next question. देखो, ये नहीं कह रही हूँ कि ये वाले क्वेश्चन ही इंपॉर्टेंट है, बट आपको सारे क्वेश्चन करने हैं, बट इनको थोड़े और अच्छे से करना है, राइट? बिकॉज दे आर गोइंग टू टेल अस द पैटर्न विच IIT Kanpur asks. So we are going to solve every question of each of the set. In 2015, in 2002, we are going 2007, we are going to solve all questions. Okay. So yeah, so this is another question. It says that which one of the following is not equivalent to P if and only if Q, right? And what is this P if and only if Q? I know that if you remember what is P if and only if Q, it is, and we know that it is, if P and Q have same truth value, it will be true, and if P and Q have distinct truth value, it will be false. And also by equivalence law, we know that that P if and only if Q is equivalent to P implication Q and Q implication P. You can check that by equivalence, these will always be equal, right? P implication Q and Q implication P. Now can you write P implication Q? How can you write? Using implication, I can write P implication Q as negation P or Q, right? And negation Q or P. So which option is true here? Now I can check that option A is true. Option A is same. Either I'll write P or negation Q or negation Q or P. Both have the same meaning. Why? Because or operation or connective is always commutative, right? Is it true? Okay. So here I got option A is my correct option. So here I'll get option A. Let's come back to option B. Let's see option B. What is option B here? Negation P or Q and Q implication P. So can I write it negation P or Q? And I know that by implication again, I can write this as Q implication P, which is what? Which is my option B. So here option B is also correct, right? But just remember guys, we have to tell them which is not equivalent, right? Not equivalent. I am taking the option which are, let's not do this, that means it is equivalent, I have to check which is not equivalent, right? Now let's see option C, negation P and Q or P and negation Q, right? Okay. So can I expand this, negation P or Q and negation Q or P? If P implication Q is equivalent to this, so I can find out this expression, with which expression this statement is equivalent. So let's see, let's take this expression. So expression here is negation P or Q and negation Q or P, right? We know distributive law, right? What distributive law does? Distributive law breaks each, I can write this as negation P or Q, negation P or Q and negation Q, right? And negation P or Q also breaks over P. So I'll get, so this will be bracket and then we have or negation P or Q and P, right? I can do that. Now let's break down it further. Right, let's break it down. Again, I can use what? I can use again distributive law from the right hand side. In this I have used from the left hand side, now I have to use from the right hand side. So let's do that. So what would I get? Negation P and negation Q, and then we have OR sign, Q and negation Q, right? This is my capital bracket. Or now again I can break this from the right, distributive law. So let's do that again. Negation P and P and or Q and P, right? Now this Q and negation Q will always be false, right? Q and negation Q always be false. Why? Because if I'll take Q true, negation Q will be false, and I know that and connective is always false whenever one of the proposition is false. So it will be always false. And if I'll take or with false, let's suppose if I'll take true with false, I'll get true. If I'll get false with false, I'll get false. So it completely depends on this one. It completely depends on the left proposition truth value. So I can write here it is equivalent to negation P and negation Q, right? Or and this will again same. Now if you will see negation P or P, negation P and P always be false, and if I'll take or connective with false, I'll get the function Q and P, right? Q and P. So just see which one of the option matches, because I have just simplify this function. Now this function is P if and only if Q is equivalent to this, and this is equivalent to this. So that means P if and only if Q is equivalent to this, right? Now let's see which of the option matches here. I can see here option D matches. Again, option D is equivalent, right? Either I'll write Q and P or P and Q, both have the same meaning because and operation is commutative, right? Now let's see, A, B, D all are equivalent. Which is not equivalent? Option C is not equivalent, because we are left with this. So here option C is my correct answer. Okay, so guys, just understand that option C is correct answer, just because sometime what students do, because we know that exam is lengthy and we have to solve questions in minimum time. So students does not study in read not, and they will first find out that A is equivalent and they will tick the option. That's why if you will see, they have written down not in capital letters, because in study they have find out that students do not do study read in, because when they are in hurry they have to attempt as many questions, they would do silly mistake. So just remember, because they have asked for not, here option C is correct, right? Okay, just let me know guys if there is any confusion. Otherwise give me a thumbs up if you are understanding the concept which I am teaching here. Just give me a thumbs up in the chat section. Just give me a quick thumbs up and then we will move on to the next question. Okay, so let's move on. Okay, so this is a set question, right? Just try it yourself and let me know which of the option is correct. Then I'll tell you that which option is correct, right? It is a question based on power set, and it is very important question, because if you will see, power set is a important topic for GATE point of view, right? So I hope all of you know what is a power set. Power set is a collection of all subset of a set, right? And we know that if set S has cardinality, let's say n, then power set has cardinality 2 to the power n. And what is cardinality? Number of elements in the set S, right? Okay, so let's see question here. So it says that for a set A, the power set of A is denoted by 2 to the power A. Generally we denote the power set of A as P of A, but here they have given us power set is denoted by 2 to the power a, right? Okay, so if a is this 5 curly bracket 6 curly bracket 7, then which of the following option is true, right? We have to, so one option is that I'll check which one of the option is false or true, right? Or otherwise I'll write first power set of a, right? By any method you can do that. Let me first write power set of a. What is power set of a? The subset of a. Phi is a subset, right? Then I'll take all the singleton sets. What would I get? 5, and then we have curly bracket 6, then we have curly bracket 7, right? Now just remember, because they have given us curly bracket 6 as a subset of a, you as an element of a, you have to take double curly brackets here, right? When you are taking a single element, right? Now let's move on. When we are taking two elements, 5 comma curly bracket 6, then we have 5 comma 7 singleton set, and then we have 6, and then we have 7, right? And how many elements we will get? Because if you will see here, how many elements? 5, 6 and 7, that means 3 elements. So our power set 2 to the power a will have cardinality 2 to the power 3, that means 8 elements. So how many elements? 1 2 3 4 5 6 7, and the last set will be a, right? Is it clear? How we write down this power set is clear to you? Okay, so this is how we write down the power set of a. Now let's back to our options. So if I'll see first option, 5 belongs to 2 to the power a, yeah, I can check that 5 is an element of 2 to the power a. Option first is a correct option, right? Now let's come to the second option. Second option says that 5 is a subset of 2 to the power a. So if you remember, we know that the empty set and the set itself, let me write down here, empty set, that means null set or phi, empty set and the set itself always subset of itself, always a subset of itself, right? It's very important, right? Either it is empty set or the subset or the set itself, always a subset of itself. Let's suppose if I'll take a as a set, then the phi is also a subset and the set a is also a subset. So that means option second is also true, right? Now let's see option third. Option third here says that, if I'll see option third, it says that 5 comma curly bracket 6 belongs to 2 to the power a. This means this complete elements has to present in this power set of a, right? I can check that this element is present, right? So that means third is also correct, right? Third is also correct. Now let's see fourth option. Fourth option says that this is a subset of 2 to the power a, and it will be subset of 2 to the power a when 5 belongs to 2 to the power a and this curly bracket 6 belongs to 2 to the power a, right? And here I can check that 5 does not belongs to 2 to the power a, right? 5 does not belongs to 2 to the power a, because this subset of singleton set 5 belongs to 2 to the power a, but 5 does not belong. Similarly, curly bracket 6 does not belongs to 2 to the power a. This curly bracket belongs to 6 2 to the power a, right? So it also does not belong. So that means this is not true, right? So you got that. Now if I'll say that a is a subset of b, then I have to check that elements of a has to be present in b set b, right? And if I'll say that a belongs to b, that means this element a has to be present in the set b. Now I can check here this 5 and curly bracket 6 does not belongs to power set of a, that's why option D is incorrect. So overall I can check that first, second, third option are correct only, so option C is my correct option, right? Any confusion guys in this question? Any confusion guys? Just let me know guys if there is any confusion at all, otherwise I'll move forward to the next question. Option C is correct here. Yeah, okay. So that is my Lu decomposition question. So do you know how to write Lu decomposition? Do you know how to write Lu decomposition? What is L here? L is a lower triangular matrix, U is upper triangular matrix, right? They says that in the Lu decomposition of the given matrix, if the diagonal elements of U are both 1, then the lower diagonal entry L22 of L is. So we have to write down the lower diagonal entry L22. So here, when if we have given that U has diagonal elements 1, right? U is upper triangular matrix, so let's write it down as U12, right? First row, second column. Then L will become, let's write down L here. So L is an upper triangular matrix. L will be L11, L21, L22, and we have 0 here. So we have to find out the value of L22, right? To find out the value of L22, I just have to find out first. I'll solve the Lu decomposition, right? I'll solve the Lu decomposition. I'll multiply L with U. So what would I get? I'll get here, let's multiply L11 and this will be L11 U12, right? And then we have L21 and then we have L21 U12 plus L22, right? We'll have this Lu decomposition. This is my Lu matrix, and in Lu decomposition I can write A is equals to Lu. A is equals to Lu. So that means Lu is equals to A matrix. What is A matrix? 2, 2, 4, 9. Let's compare the values to find out L22. Right? Can I compare that? Okay, anybody from the chat section, just try to do it by yourself and let me know what will be the value of L22 here. You just have to solve the equation, because if you will see here we have 4 variables and we'll get 4 equations from here. So I can easily solve it. Okay, so let me compare. Just you also try to solve by yourself and let me know the answer in the chat section, right? Okay, yeah. So if I'll compare, I'll get L11 equals to 2, and from the second equation L11 U12 equals to 2. Now if I'll put L11 is equals to 2, what would I get? I'll get U12 equals to 1, right? Now from here I'll get L21 equals to 4. Now the last equation will be L21 U12 plus L22 equals to 9. L21 is my 4, U12 is my 1 plus L22, that is equals to 9. So from here on solving L22 I'll get 5, right? L22 is equals to 5, and that's the value which I have to find out here, right? So what is a L22? L22 is 5. So here 5 is my correct answer. Right? Any confusion guys in this question? I hope there will be no confusion. Let's see next question. 5 is answer here. Okay. Yeah. Okay, so in this question we have to find out summation I varying from 1 to 99 1 by x into x plus 1. How to solve these type of question, because we do not know any formula regarding sum and all, right? So whenever you will see something like this, just try to find out the partial fraction, right? Do you know partial fraction? Because if you will see in the denominator we have product of linear vectors, so I can break it down. I can break down 1 upon x into x plus 1 equals to 1 by x minus 1 upon x plus 1, and you will see you will get the same answer, right? Now when you will apply summation x varying from 1 to 99, so over this also summation x varying from 1 to 99, right? Now let's see what we will get from here. So if you will try to solve it, let's put 1. What would I get? 1 minus 1 by 2 plus, if I'll put 2, I'll get 1 by 2 minus 1 by 3 if I'll put 3, 1 by 3 minus 1 by 4, ongoing in this way. Last term I'll get is 1 by 99 minus 1 by 100, right? Now you can cancel out some terms here. If you will see, there are some terms which you can cancel with each other, right? Let's see, you can cancel out 1 by 2 with 1 by 2, and similarly there will be 1 by 3, 1 by 3, similarly 1 by 4, 1 by 4, similarly if you will see, you will get 1 by 99 and 1 by 99. You are only left with 1 minus 1 by 100. On solving you will get 99 by 100, which is my 0.99. So here 0.99 is my correct answer, right? Easy. Just remember, whenever you have given product of linear factors in denominator, just try to take a partial fraction and then expand it. You are going to simplify by cancelling out some terms. Okay, so I hope it is clear to everyone. Let's see next question. 0.99 is my answer, right? So this question is from my graph theory, right? So guys, you can see that we have started with calculus, we have seen composition of function, limit, and then we have matrix question, and then we have solved Lu decomposition, right? So and now we have a question from graph theory, and you will see that graph theory question is easy here, right? G be a connected graph with 10 vertices, that means n is equals to 10. If the number of edges on each face is 3, the number of edges in G, that means we have to find out E, and we have given that each face, number of edges in each face, number of edges on each face is 3. So that means 3f by 2, total number of edges. Why? Because 3 edges on each face, and we know that every edge is also every edge is on 2 faces, right? Let's suppose if I'll take this, let's say this one. So if I'll see this edge is for this face also, and this edge is for this face also, and if I'll consider this edge for this outside face, right, outside region, and for inside region also. So every edge has 2 regions, so that's why we have divided it by 2. And to solve this, we have some formula, right? What is the formula? We have a formula, n minus e plus r is equals to 2, or you can say that f, right? And this formula is when the graph is connected, right? This formula is when the graph is connected. When the graph is not connected and has k components, k connected components, then the formula will be n minus e plus r is equals to k plus 1, right? And with this I got this formula. When I have a connected graph, that means one connected component k is equals to 1, so I'll get this formula, right? So let's see here, n minus e, 10 minus 3f by 2 plus f. So from here I'll get 10 minus 2 is equals to 8, and 3 by 2, let's solve this. So what will we get? 3 f by 2. So I'll get f is equals to 16. So now let's find out, we have to find out number of edges, 3 into 16 by 2. So from here I'll get 24. So here my 24 is my correct answer, right? Easy one. This question is easy, right? We just have to remember this formula, and that every edge is considered in 2 regions, right? Then we can write edges is equals to 3f by 2. I hope this is clear to everyone. Just let me know, guys, if there is a little bit confusion, you can ask me. You can ask me in the chat section, because it's very important. If you are giving your time here, you should understand something, you should take something from here, right? So that's why I'm also revising you the concepts, that if we have k components, then we have this formula, right? You are going to revise all the concepts which they have asked in 2015 questions. Okay, let's see next question, if there is no confusion at all in this. Okay, yeah, we have solved this. Yeah, okay. So this is my integration question again from calculus, right? So just remember, if you will see the pattern, they will always going to ask a limit question, a integration question, a question from Lu decomposition, right? Oh, मैम कॉमन एज भी गिनी जाएगी क्या? Because of that common edge, we have divided by 2. We have divided 3f by 2, right? Okay, so let's come back to this question. So what will we do? Now if you will see here, we have this function 1 by x here, and the derivative, we know that derivative of 1 by x is minus 1 by x square, and which is present here. So what will we do? We will take let t is equals to 1 by x, right? We are going to use substitution here. Why I am going to use substitution? Because I am finding one function derivative present here, right? So let's take t is equals to 1 by x, then dt is equals to minus 1 by x square dx. So I can write minus dt 1 by x square dx. Now students, what kind of mistakes students do in these type of question? Students forgot to change the lower limit and upper limit of integration, right? Whenever you are using substitution in definite integral, limits are also going to change, right? Limits are also going to change. You can't forget this, because if you forget this, you are not going to get the result, right? So let's see, when t is equals to when x is equals to 2 by pi, then x is okay, so when x is equals to 2 by pi, you will get t is equals to pi by 2. When x is equals to 1 by pi, which is lower limit, you will get t is equals to pi. Now let's integrate, right? So let's integrate. So limits of integration, when we have 1 by pi, it gets changed to pi, and when we have 2 by pi, it gets changed to pi by 2. Cos 1 by x is cos t, and 1 by x square dx is minus dt. So that would be minus dt. Let's integrate. Integration of cos t is sin t, right? Formulas of differentiation and integration should be on your tips to solve these type of question. Integration of cos t will be sin t. I also have sometimes this confusion that integration of sin t is minus cos t, or integration of cos t is sin t, right? There is always a minus confusion, right? What you can do, you can write d of differentiation of sin x is cos x, so integration of cos x will be sin x, right? And differentiation of cos x is always equals to minus sin x, so integration of sin x is equals to minus cos x, because we know that differentiation and integration are inverse process. So that's why you can revise the formula of integration, right? Okay, so integration of sin t, and this minus sin minus dt, right? Pi to pi by 2. So let's put the value, minus sin pi by 2 minus 1, minus minus plus, and sin pi 0. So we'll get the value of the integration is minus 1. So here minus 1 is my correct answer. Any confusion guys in this question? This one was easy, right? You just have to use the substitution method, right? Just use the substitution method, and what you have to keep in mind that you have to also change lower limit and upper limit at the same time, right? Okay, so let's see next question. Minus 1 is my answer, right? Okay, let's just wait for 1 minute. Let's just wait for 30 seconds here. If anybody have the confusion, then I'll move forward. Okay, so let's see next question. Yeah, it's a question from linear algebra matrix. It says that consider the following 2 cross 2 matrix A where 2 elements are unknowns and are marked by A and B. Okay, the matrix is given to us 1, 4, AP. The eigenvalues of this matrix are -1 and 7, and what are the values of A and B. We have to find out the values of our A and B. Now, if you remember, either what you can do, you are trying to solve the matrix A with A minus lambda. You will find out the determinant of A minus lambda and you would try to find out the eigenvalues, and you can put lambda minus 1 and lambda minus 1 and 7, you will get two equation, you can solve it. You can do this by this method also, but this would be lengthy, right? I just have to take the determinant A minus lambda I, then I have to solve this determinant, and I have some kind of quadratic equation with also constants A and B, right? So I don't want to go in this mess. So what I'll do, I'll know the formula, that sum of eigenvalues is equals to trace of a matrix, right? What is trace? Sum of diagonal elements. Sum of eigenvalues is equals to trace. So what is eigenvalues? Minus 1 plus 7, and trace is equals to 1 plus A. So if I'll solve this, I'll get A is equals to 5. A is equals to 5, right? Now how would you find B, right? We have another property which says that product of eigenvalues is equals to determinant of the matrix, right? These two properties are very important. Just remember these two properties. Product of eigenvalues will be minus 7, and if I'll find out the determinant A minus 4B, I can put the A minus 4B, I can put the value for A. What would I get? 5 minus 4B minus 7. I'll solve this. 4B is equals to 7 plus 5, 12. So from here I'll get B is equals to 3. So A 5, B 3. Which option matches? Option D matches to my answer. So here D is the correct option. D is my correct option because I got from here A is equals to 5 and B is equals to 3. It's up to you. Either you want to use eigenvalue method, you can also use that. You can also use eigenvalue method if you want to do that, right? Just let me know guys if anybody have the confusion, right? Let's see next question. Yeah, this is my second last question, right? So we have covered all questions from engineering mathematics, discrete mathematics, and let's see. So this is a question, the binary operator is defined by the following truth table, right? This is a question from propositions, from connectives, right? What we have learned some kind of connectives, right? Here is we have given different type of connectives. You can consider that. If you will see, 0 and 0 not equals to 0 will give me 0 here, right? And 0 not equals to 1 give me 1, 1 not equals to 0, 1 not equals to 1 give me 0. Now they ask me that this binary operation is commutative or associative. Yeah, Vishnu, we in that self-paced course we have covered each and every topic, and we have covered previous year question also. And if you want to practice more, you can go on our website, GFG Gate. If you will write GFG Gate, you will get all the notes and you will get all the questions to practice there. You can also practice from there. Otherwise, the course is sufficient. You just have to practice question, because in mathematics, if you have understand the concept, you just have to practice question, right? Because there is most of the chance that students will do some silly mistake, right? Because you know the concept, you just have to practice it. So try to practice some questions, and yeah, you can get the full marks, right? Okay, so this binary operation, which one of the following is true about this binary operation, right? Let's talk about commutative. You can see that if we are going to discuss 0 not equals to 1 give me 1, and 1 not equals to 0 also give me 1. So that means these are commutative, right? because if I'll do 0 not equals to 1, I'll get 1, 1 not equals to 0, I'll get 1, right? So I can say that it is commutative. Now what about associative? Also, what is associative property? Associative property is, if I'll do ABC or ABC, I'll get the same value, and you can check that by taking any value for A, B and C, 0 or 1, you will get that it is associative. You can try some option, you will get that both commutative and associative, right? Okay, so this is my, now we have our last question, this one. This is from lattice, right? Okay, so let's see this question. So it says that L be a set PQRST is a lattice represented by the following Hasse diagram, right? This is my Hasse diagram. Okay, we have PQRST this type. For any xy belongings to L, not necessarily distinct, x or y and x and y are join and meet. What are join and meet? X or y is my least upper bound, x and y is my greatest lower bound, right? Least upper bound of x and y and greatest lower bound of x and y, right? This is my definition of join and meet, right? So it says that let LQ be a tuple which has 3 elements, x comma y comma z, x comma y comma z belongings to L, be the set of all ordered triplets of elements of L. Not tuples, they are triplets, right? Let PR be the probability that any element x, y, z belongings to LQ chosen equiprobably satisfies this x or y and z, x or y and x or z. So it's basically my distributive law. So I have to find out the probability of the elements of x, y, z which follows this distributive law, right? I have to check that. So how do we do that? Right, so I have to take some elements to check that, right? I have to do that. So let's take, if I'll take x is equals to t, let's see, let's take some bigger elements here. Let's take x is equals to t. If I'll take x is equals to t, no matter what y and what z I'll take. Let's suppose I am taking one example, y is equals to r and z is equals to, let's say, s. If I'll find out x or y and z, y and z will be r and s, will be t, x or t. What is x? Let's replace x with t or t. So y or z, y and z, sorry, it will be greatest lower bound. Y and z will be greatest lower bound. So greatest lower bound for r and s will be p, t or p, t or p. So what would we get? Let's see, t or p. For t or p, least upper bound will be t, right? And if you will take x or y and x or z, if you will take x or y, you will get t, and for this you will get t, right? So just remember, when you will take, let's replace this, when you will take x is equals to t, no matter what values you will give to y and z, you will always get this condition satisfied, right? And if you get this condition satisfied, so for how many cases you will get this condition satisfied? Y can take how many values? 5. Z can take how many values? 5. So for 1 into 5 into 5, this condition gets satisfied. So we have 25. And how many elements in this LQ? 5 into 5 into 5. Total number of elements 125, right? Now let's see. Let's take x is equals to p and y is equals to, let's take r, and let's think about some distinct values, right? X is equals to r, let's take this, x, let's take x is equals to r, y is equals to p and z is equals to p. Let's take this value. If I'll find out x or y and z, let's find out x or y and z. P and P will be P and R or P. R or P, R this and P this, and we have to find out least upper bound. So least upper bound will be R. Now x or y and x or z. What is x and what is y? R or P. R or P will be P. R or P will be, sorry, R or P will be least upper bound. So it will be my R. So it will be my R. R and R. And if I'll solve R and R, so I'll get R. So that means I'll get this 25 cases and one more case I get from here. That means 25 plus 1, 26. So that means probability is always greater than 26 upon 125. Greater than, equal to. There may be a possibility it would be equal to. So that means probability is greater than 25 by 125. So that means it is greater than 1 by 5. 1 by 5. Right? So either it is option D or it is option B. I just have to check this probability is not equals to 1. Right? If it is probability equals to 1, I know that it is greater than 1 by 5, but I don't know that it is equal to 1 because it says that it is strictly less than 1. So both options cannot be true at the same time. So let's see some example. Let's take x is equals to P, y is equals to Q, and z is equals to S. P, Q, z is equals to S. Okay. And let's say RQS. Now let's find out RQS. We have taken R, Q and S. So okay, no, not take RQS, let's take QRS. Right, you just have to check some by taking examples, right? Q, R and S. Yeah, that is little bit difficult. That is little bit difficult to get to the result because you have to find out one which is not true, and in this case you will see that this statement, this condition is not true. Right? Oh, so yeah, my name is Sakshi Singhal. Okay, so for this condition x, q, r, s, let's check once. So what we have to find out, x or y and z. For y and z, r and s. So what will be the greatest lower bound? That would be p. So q or p. So in this case, what will we get? Q or p? We'll get q. Right? We will get q. Right? Now we have to check the second condition, x or y. X or y and x or z. So x or z. So for x or y, q or r, what will we get? Q or r? That would be t. And x or z, that means t or r, t or s. Right? That would again, sorry, x or z, that would give me q or what will be z? Q or s. So q or s will be t. So from here I'll get t. So I can see that this condition does not get satisfied with q, r and s. Right? If this condition is not satisfied, that means it is not equals to 1. So which one of the option left? Option D left. Right? This is a little bit different. You just have to take some different triplets and get to the result. Right? So that's why you just have to work on these type of question. That's why I told you that you have to practice question after learning the concepts. Right? Okay guys, so that's all from my side in this video. You just have revised all the question from GATE 2015 set 1. So we are going to discuss more question, which the class will be on Wednesday, and we are going to discuss more questions again, right, from set 2. Right now, and if I'll recall what kind of concepts I get here, right, what kind of concepts? One is Lu decomposition, that means it is important, limit, continuity or composition, function composition, and another one we have found one question from graph theory, which is from connected set, right? Connected set. Okay, and then if you have confusion in any of the topic, just go back to the class, just go back to your notes and revise that. Lu decomposition, limit function decomposition, graph, and also we have one, let's see once again. Okay, binary operation, yeah, eigenvalues. One question is from eigenvalues, and also one question, the last question is from lattice, right? So just revise these topics and you can, we are going to work on set 2, right? Okay, so that's all from my side. We'll continue in the next session.